Hey everybody, welcome to this next video lesson. In this video lesson we're going to talk about how you do the electron configuration of ions. First thing we need to talk about though are what are ions. Now you might have learned about this in a previous science course, but we're going to talk about it yet again here. Now ions are particles that have an overall positive or negative charge. Now in order to create an ion we need to either add or subtract electrons because we can't change the protons because that would change the particle. So what we need to do is to change the electrons. Now if we have a negative ion, which is called an anion, what we have is an extra electron compared to the protons in the nucleus. If we have a positive ion, which we call a cation, then we have less electrons in the atom compared to the protons in the nucleus. If electrons are all negatively charged particles, then it makes sense that if you add more negatives, then you get a negative ion. And if you take away negatives or subtract negatives, that results in a positive. And that is true of ions. Both positive and negative ions have to do with the removal or addition of electrons. So let's talk about what happens when positive ions are formed. And when positive ions are formed, as we just talked about in the last slide, we lose electrons. Now, if we lose electrons in reverse order in which we fill them, this would be very easy. But in fact, the way that elements lose electrons is not the same way in reverse in how they fill. Take, for example, titanium down here. It ends as a 4s2 3d2. Now, up here we talked about how when we remove the electrons, we actually go from the highest energy level first. Not highest orbital, but highest energy level first. And so I'm going to remove the electron from the 4th energy level because it's higher energy level than the 3d, even though the 3d is slightly further from the nucleus than the 4s. So if you look down here, my titanium 1+ has lost an electron, and you can see that I have removed an electron from the 4s2 to become a 4s1. Keeping the 3d the same, it's still 3d2. Now my next electron lost is going to be once again lost from the 4s. So now I'm going to remove that 4s electron, and now I have no electrons on the 4s, leaving me with just 3p6, 3d2. Now, once I've removed all the electrons from the highest energy level, any additional electrons then remove from the highest orbital next, which in this case is d, followed by p, finally s. So when I remove the 3rd electron from titanium to make 3+, that electron now can come from the 3d orbital. So in summary, we want to remove from the highest energy level first, then go down until that energy level is empty, then remove from the highest energy orbital. Now if I remove a 4th electron from titanium to make +4, now I remove that 3d electron and all that's left is 3p6. Now these positive ions have these two little bullet points that you have to remember. But when it comes to negative ions, well, just build it with extra electrons. Fill up the orbitals the same way you would fill up orbitals if you were building an atom from Aufbau principle, starting from 1s and moving to 2s and so on and so forth. So for a negative ion, just add electrons to the available energy level in orbital. You don't need to worry about highest energy level or highest orbital like you do for positive ions. So let's take, for example, nitrogen 3- here. If I want to make nitrogen, well, nitrogen has 7 electrons, so that's 1s2, 2s2, 2p3. That's 7 electrons. But I wanted 3 additional electrons because this is a 3- charge. And so instead of 7, now I have 10. Well, I'm just going to add those electrons into the p orbital until I have 10 total electrons. So I have 1s2, 2s2, 2p6. And that's actually quite an observation because almost all ions want to achieve the same electron configuration as a noble gas, and neon in this case has 10 electrons, which is a noble gas configuration with p6, which is the same as nitrogen with the 3-. And so in negative ions, we just build electrons, add them into that orbital until we get to a p6, and typically at that point we're done. Well, that takes care of this video lesson on electron configurations for ions. Thanks for watching.